Greetings to all of the judges. My name is Dawson Chan and I'm from Group Pelajar-Pelajar. So today, we will be presenting to you our project, namely TinyHarvest. In Southeast Asia rapidly growing cities, many people dream of growing their own food on balconies, windowsills or small indoor spaces. But urban farming often fails because of three big barriers: lack of clear guidance, lack of confidence, and lack of ongoing support. So who is really affected? The four groups hit hardest are urban compartment dwellers with limited spaces, beginners who fear failure, busy professionals who have no time for research, and families with children who want a safe, guided experience. These are exactly the people what we are here to help. Our project strongly aligns with the United Nations Sustainable Development Goals. It supports SDG 2, Zero Hunger, SDG 3, Good Health and Well-being, SDG 11, Sustainable Cities, and SDG 12, Responsible Consumption and Production. We believe small actions in our homes can contribute to big global goals.
So now I'm going to introduce TinyHarvest, an AI-powered microfarming companion. This is a full-stack web app that transforms any small space, whether your balcony, windowsill, or even a shelf, into a thriving personal garden. TinyHarvest features 6 AI-powered tools that cover the entire planting journey. First, it analyzes your space and climate using your location and a photo. Then, Smart Plant Matching recommends the best plants for your environment and lifestyle. Once selected, it creates a personalized growth timeline with weekly tasks. Each week, AI checks your plant health through image analysis and gives actionable advice. If you already have a plant, it can sync your current growth stage instantly. Finally, when it's ready, it suggests recipes so you can enjoy what you grow. From seed and plant, everything is guided by TinyHarvest. As you can see on the left, the data flows in a clean pipeline. The front end sends requests. The back end routes them to either the database for storage or to Gemini for intelligence, which is climate analysis, plant matching, health diagnosis, then send clean, validate response back to the user. Also, every AI code has a graceful fallback, so if Gemini goes down, the user will never be blocked. Now, for full transparency, here's how AI powers TinyHarvest. We use Google Gemini 2.5 Flash as our core intelligence engine and anti-gravity as our development assistant. As you can see, every key features I show you is powered by Gemini. Now I'm going to introduce the AI-powered code editor behind TinyHarvest. We use Lovable to speed up development with intelligence code generation, quickly building React and TypeScript components, page and styling. Its design system keeps our interface consistent and modern, while real-time debugging helps us to fix issues efficiently. With seamless back-end integration, we handle database, authentication, and server-side logic with ease.
Here is our homepage. We highlight top-yield edible plants like Chili Buddy to help users quickly decide what to grow. When a user clicks on a plant, they can see key details such as difficulty, time, savings, recipes, and health benefits. The whole process is simple. User enters their space, get personalized recommendations, and follow guided steps to grow and harvest. When users click on Start Growing, they are guided through a setup process. First, the system automatically detects their location and analyzes climate factors like temperature, sunlight, and humidity. Next, users can upload a photo of their space for AI-based environment analysis. Finally, users input their lifestyle such as time commitment and experience level. All of this allows us to generate highly personalized recommendations. This is the My Garden page, which is the core of our platform. Plants are organized based on where they are grown, such as backyard or indoor spaces. At the top, users see Today tasks, which clearly tells them what action to take. Each plant has 2 states, which are in progress or ready for harvest. The Quick Action button allows users to easily log activities like watering and fertilizing. And after all, everything is recorded in the growth diary, helping users track their progress over time. We also provide a guided course that teaches users step by step from the very beginning, reducing the fear of failure for beginners. They can follow weekly instruction and even upload photos for AI analysis, which is also saved into the growth diary for continuous tracking. Users can add new plants either by browsing categories or using AI recommendations tailored to their environment. After harvesting, users can review their food journey and access recipes using their homegrown ingredients, making the experience both practical and rewarding. Next, we have the AI Health Assistant. Users can upload a photo of their plant and the AI will detect diseases or nutrient deficiencies, provide causes, and suggest organic treatments and prevention methods. This allows users to solve problems quickly without expert knowledge. Finally, we have the community feature. Users can connect with other urban farmers, share their progress, ask questions, and learn from real experiences. There are also trending topics and discussion, making it easy to find relevant advice. This builds a supportive ecosystem where users not only grow plants, but also grow together.
With our solution, we aim to create real impact. We empower individuals with self-sufficiency, encourage healthier eating through fresh homegrown produce, and make gardening simple and fun, especially for children. For scalability, we plan community harvest features, IoT soil sensors, and hyper-localized guidance that supports Southeast Asian languages and climates. Our vision is to turn every small urban spaces into a productive, confident garden.